Greetings everyone, my name is Shyong and I'm going to talk about my engineering quality control assignment. It is about data analysis. So here's a brief introduction into my assignment. Responsible consumption and production is a sustainable development goal that aims to reduce waste and ensure efficient use of resources in manufacturing. Statistical process control is a quality tool that can help industries optimize their production process towards the end, contributing to more sustainable consumption and production patterns. So in this assignment, charts and conclusions based on the provided dataset will be made. Here's the sample of my dataset obtained. So in order to create charts, I'm using R software. So what exactly is R software? R is a programming language for statistical computing and data visualization. It has been adopted in the fields of data mining, bioinformatics, and data analysis. So why do we use R? R software has an interface that is very organized, so the users can view graphs, data tables, R code, and output all at the same time very clearly. Here's my control charts. For machine 1, we know that the mean is 49.89754 and the standard deviation is 0.592164. And the process is in control. As we can see, all subgroup value falls between upper control limit and lower control limit, which also stands for UCL and LCL. For machine 2, the mean is 48.6475 and the standard deviation is 1.055617. However, there is a subgroup out of control, making the process out of control as well. For machine 3, you can see that the mean is 51.92537 and the standard deviation is 0.6500515. We also can see that there is a subgroup out of control as it falls out of the LCL, making the process out of control. Next, we have process capability chart. By referring to the process capability chart for machine 1, we also obtain the same value from what we obtained from the control charts for the mean and standard deviation. The main thing is to obtain the CPK value and the CP value. The CPK value is 2.76 and the CP value is 2.81. Both of the value meets the specification limits. For machine 2, we also obtain the same value for mean and standard deviation from the control charts. And the CPK value is 1.15 and the CP value is 1.58, both meeting the specification values. For machine 3, we also obtain the same value for mean and standard deviation. As for the CPK and CP, CPK is 2.56 and CP is 1.58. Both also meet the specification limit. Now we're going to talk about analysis of variance, which also named ANOVA. Here's two-factor ANOVA for machine 1. Whenever PR greater than F is smaller than alpha, the factor is considered significant as stated above. So we assume that the alpha is equals to 0.05, and in the table provided, we can see that the value for the temperature and pressure for the PR greater than F is smaller than 2e power minus 16. We can assume that the small value is 0. Hence, it will be smaller than alpha. So for the machine 1 resistance, PR greater than F for the pressure and temperature is 0. Therefore, both of the factor is significant for machine 1. And for the PR greater than F for the pressure multiplied by temperature is 0.698, making it greater than the alpha value. Hence, in this factor, P times T is not significant for machine 1. Here's the ANOVA for machine 2. As we can see, it repeated the same pattern with machine 1. Both of the factor, pressure and temperature is 0, making it smaller than alpha. Hence, it is significant for machine 2. And the PR greater than F for the pressure times temperature is 0.799, making it greater than alpha, which is also, in this factor, P times T is not significant for machine 2. Move along to machine 3, we can also see that PR greater than F for the pressure and temperature is 0, hence making it smaller than alpha. However, the pressure times temperature value is 0.00303. It is smaller than alpha. Hence, in this vector, P times T is significant for machine 3. So here's a little comparison between 3 of the black spot plotted. We can see that there is only minor significance in all 3 machines. Now we are going to compare these 3 machines based on the data we have analyzed. From the table, we can see that only machine 1 has the process in control. As for machine 2 and 3, they have outliers which makes the process out of control. And for the number of violating runs, machine 1 and 2 is same at 2, and machine 3 has 4 number of violating runs. As for the value for CPK and CP, machine 1 is 2.76 and 2.81 respectively. Machine 2 is 1.15 and 1.58 respectively. And lastly, machine 3 is 1.58 and 2.56 respectively. Now we can make a conclusion on which machine is the best to be recommended for the industry. It is machine 1. To recap, let's take a look at the control chart. Machine 1 is the only machine without any subgroup points falling out of the control limit line, which is the upper control limit and the lower control limit, making it a controlled process. As for the process capability chart, we obtain that machine 1 is the highest process capability index at 2.76 and 2.81 for CPK and CP respectively. So how do we look at this CPK and CP, the process capability index? The minimum process capability index is usually established at 1.33, and the minimum process capability index here is 2.81, which obviously has exceeded a lot. And for the CPK, it usually must be greater than 1 to be capable, and if it's greater than 1 in a greater value, it means that it has exceeded the specification limits in a greater value. Lastly, we can also see that machine 1 has the smallest standard deviation at only 0.592164. And for the analysis of variance, which is ANOVA, only pressure times temperature factor are not significant, but pressure and temperature are both significant factors for machine 1. And that is all for my presentation. Thank you.